Alright guys, this is on using data displays. Basically this whole section is just about different ways to display different types of data. And you can see you've got two vocabulary words I'd like you to copy in there. Categorical data and numerical data. Obviously this one right here, let me get my pen on here. This one that says numerical data is going to be something to do with numbers. Okay, this one right here. And, oops, let me change colors here. Get a neat color like that one. That works. Okay, this one right here is something to do with numerical data. Alright, and anything that has non-numerical data in it is going to be called categorical data. Now that doesn't mean all the data is without numbers. It just means that some of the data may be without numbers. Okay, so I'm going to scroll this up a little bit and just go through this. I don't believe you have this on your note packet, so I would like you to copy this down. It doesn't have to be word for word, but just kind of get the idea here. The different kind of representations we can make. If we have some data that includes time in it, a lot of times we use a line graph. I'll give you a little example. In earth science, a lot of times we have a lab, alright, where we have like a light up here, and that light is giving off some radiation, and we will put maybe a cup down here with a little thermometer sticking out of it, and a little cup over here with a little thermometer sticking out of it, and maybe this is a black cup, and this is a shiny cup, and we will turn our timer on and measure the temperatures over, say, 20 minutes of this black cup and shiny cup. That would be time versus temperature. Alright, so that would be two numerical sets of data, and one's over time, so we use line graphs in earth science quite a bit. Okay, another kind of plot that you can use is called a scatter plot. Again, numerical data. Maybe this would be something like the games of bowling. Maybe you're going bowling, right? And you can play 1 game, 2 game, 3 games, 4 games, 5 games of bowling, but a lot of times your scores don't really add up. You could play 1 game and get a 300. Okay, you could play 2 games, and maybe they add up to 225 because you had really bad games those 2 games. You could play 3 games, and they could add up to 375. Okay, that would be good to use a scatter plot for. All right, and then you put it a line of best fit. We've talked about those before. You could use a bar graph. All right, a lot of times with bar graphs, see how it says compare with categorical data. That is used for something maybe I don't have some numerical data in one of my sets. Okay, an example of that, maybe you're watching cars go by and you're working for a company that is taking a survey on, what kind of cars are around this area, and you have maybe Toyota, and I cannot spell Toyota. All right, Toyota, and you have Ford, and you have Chevy, and you count how many of them go by, how many Toyotas, how many Fords, etc., how many Chevys. Maybe you see only 2 of those. And so you have some non-numerical data over here and some numerical data here. A lot of times a bar graph is good for that. Circle graph, a lot of times that is when you're breaking like a big part of something up into little parts. I'm thinking maybe a family budget, and you have this percent goes towards food, and maybe this percent goes towards your rent or your mortgage for your house. This percent right down here goes for entertainment. Okay, this percent we want to put some away into savings. Okay, and this percent is something else, and this percent is something else. So a circle graph, or a lot of people like to call it a pie graph, will be when you're breaking a whole into parts. Stem or leaf plot, that's another one. Maybe you're talking earth science again, and you're taking temperatures. We've talked about stem and leaf plots before, but a lot of time temperatures are they're very similar. You know, you might have 39, and then you'll have some in 40s and 41, and notice they all have a common root. Like these all have 3s as a root, okay, and these have 4s as a root. So you do a stem and leaf plot and see how many 30s you have, how many 40s you have. Histogram, kind of similar to the stem and leaf plot. You could maybe do a histogram where you're grouping these temperatures. You know, how many cities have temperature between 30 to 39? How many cities have temperatures from 40 to 49? How many cities have temperatures from 50 to 59? Okay, and you'd be listing how many are in here. Maybe you have 3 of them that have, or 4 of them like I do here in the 30s, 3 of them in the 40s. Maybe you have 8 of them in the 50s. Okay, so that might be an example of a histogram use. Box and whisker plot. A lot of times when I think of box and whisker plot are test scores. You know, you guys will take the ASVAB test. All right, that is a test for the military. And a lot of times they will group the scores into the bottom 25%, the next 25%, the 50 to 75%, and the top 25%. You know, and that would be good for a box and whisker plot. So just make sure you kind of jot down these, what they might be used for. I know I got a lot of scribbling over here, but I kind of talked as I went through these. But basically, we're going to look at a few scenarios and just decide, which would be better or which would be not good or what have you to use with these different situations. Okay, so here's your first example, and what they've got here is a survey that was taken, and people were asked what day of the week that they went to the grocery store. So you can see every day of the week is listed here, and you can see that Tuesday was the day to go to the grocery store because not many people are there, but one of the most popular days is Saturday. Makes sense because a lot of people are off work. But we want to just fill some things in here about this survey. The responses to the survey consist of the days of the week, which would be categorical data, okay, or categorical, I should say. So I'm going to fill in right here, categorical. All right, and the reason why it's categorical data is because this set right here doesn't have any numbers in it. Okay, like I said before, categorical data can have numbers, but just not both of them. All right, so that is definitely categorical data. Alrighty, the sum of all these percents, since we did every day, the sum of all these percents should add up to 100%, which it does if you check it out. So also the sum of the percents is 100%. Alright, so you guys want to get this in your note packets here. So you could use, since we've got percents here, and they add up to 100%, you could use a circle graph, okay, or a pie chart. Also, since you have categorical data, you could use a bar graph. All right, that could definitely be used there. Bar graph. I don't think I can fit graph in there, so I'm just going to put it down there. Okay, so that's kind of like the idea we got behind this one is just what can be used. Okay, so you can see there's more than one answer too. You can use a circle graph, you can use a bar graph. You definitely wouldn't want to use a line graph here. I mean, you would have Sunday, Monday, Tuesday, Wednesday along the bottom, and it just wouldn't make sense. All right, so you wouldn't want to use a line graph there. So what we'd like you to do is to try this checkpoint and do the same thing. Which display can you use to display the data? So go back to that list of different types of displays, look at the data, and see what kind you would choose. Okay, so you can see my answer popped up there. It's definitely numerical data. Both of these have numbers in it, and I would use a scatter plot. All right. You maybe could say a line graph, although really line graph is if one of these had time involved in it. Okay, so I would definitely call it. It's basically very similar things, but scatter plot is really the right name to call it. Okay, so I'm going to turn that one off. I'll put this one on here. We got to adjust as we go here. So pull that down a little bit. Okay, so you've got a bar graph over here. Actually, this is a histogram over here because these are grouped, or these are groups, okay? And then you've got a box and whisker plot up here. And using the histogram, the economist can compare the number of what in each interval, okay? So this letter A here goes with this A right up here. And this is the number of consumers, and this is how many consumers fall in these intervals. Okay, these are the average weekly grocery expenses for these consumers. So you can see between $10 and $19, there's one person that spent between $10 and $19. Between $30 and $39, this is 10 people that were surveys. Okay, so using the histogram, the economists compare the number of consumers in each interval. All right, so I'm going to put the word consumers right in here. All right, and that's what I want you to put down in your packet. For example, the economists can see the average weekly grocery expenses for 5 of the consumers is from where to where. Well, I go over here, and right there is 5, so I'm going to go straight over, and it looks like these people right here, there's 5 people that spend between $50 and $59. Okay, so I'm just going to put a 50 and 59. I'll put a little dollar symbol up there. Okay, because that's what that is. All right, well, the average weekly grocery expenses for, and this is how many of the consumers, is from 30 to 39. So I go for the interval from 30 to 39, and 10 people in there. Okay, so 10 different people. So you can see the kind of information you can grab from a histogram. You're really looking at groups of people or groups of data and how many are in each one of those groups. Okay. So then this next one here goes with this box and whisker plot. Okay, I wonder if I can grab onto that and move that down a little bit. Let's see if I can get my hand. There it is. I'm going to move the hand up there and get rid of that. And I'm going to see if I... Oh, no, I can't just move that. Oh, that's a bummer. Okay, well, anyway, we'll make do here. All right, so I got this box and whisker plot. They've given me the numbers right here. It says, using the box and whisker plot, the economist can easily divide the average weekly grocery expenses into low, middle, and high groups, approximately for equal side. For the example, the economist can conclude that... Move this down at about how many of the consumers spend $32 or less. Okay, so if I look at my box and whisker plot right here, here's $32. All of these people in here would spend 32 or less. All right, and if you remember the box and whisker plot, this is sectioning this into quartiles. All right, so from here to here is the first quartile, or the first 25%. Okay, right in here, that is the second quartile area. So that's 26 to 50%. All right, et cetera, et cetera. All right. So the economists conclude that about from 10 to 32, about 25% of the people fall in that little category in there. Okay, so 25% of the consumers spend $32 or less per week on groceries, and how many spend from $32 to $45 per week? Okay, so that is going to be all of these people in here. Well, if this is 25% and this is 25%, then from here to here, okay, 32 to 45, that's going to be about 50% of the people. Okay, so again, this is what I'd like you to put down on your note packets there. Okay, put a percent sign in there. Okay. All right, still mastering this whole little tablet thing, so excuse my penmanship. All right, we're going to put this up here. We're going to turn this off. And we're going to do this last example here. This is a bar graph that displays a household's monthly electric bill from September to February. Okay, and this is an example of how things can be misleading. Okay, you can look at this graph and you can say, oh, well, wow, it really goes up in January and February. Okay, it went up a little bit in November and December. But someone would look at this and they'd go, September, and look at January or even February, and they'd say, well, that's not too bad, okay? But the broken vertical axis here, all right, this exaggerates the differences in the bar lengths. For example, if you look at February, it looks like it's about 3 times the height of this one over here, okay? But if you actually look at the numbers, that is about $47, say, for September, okay? And February over here is really only $70, okay? And if you look at the bars, they look, like I said, that looks about 3 times as big as that one over here. But really, if you look at the numbers, look at that, it's only about 1.5, not even 1.5 times more. Okay, so I guess this whole example really is trying to show you that the way you display the data, okay, can be misleading sometimes. All right, so the assignment that you come in and do will just be maybe making some of these tables or data charts, but then looking at some and trying to draw some information off it and see, is it better to do it in this kind of chart or that kind of chart, and what can be misleading about some things as well. So that's really it for this one. Not much real math to it, I guess, but just a lot of vocabulary and what charts to use when. So see you later. Thanks for watching.